what is oftentimes also called a constructed wetlands system for cleaning water. In this case, sewer water. Okay, when you look at systems to clean used water, there's two classes. There's gray water, which is usually the water from our kitchens and showers, so soap and kitchen waste, grease. And then there's black water, which is those things, but also with poop in it, basically. Right? So before we installed this system here a couple of years ago, all of Pucra's sewer water was just going straight into this creek, and that would flow down into the larger river, the Toavunchi River, which is a river that flows past Siempre Verde, higher up. That river flows down this way. And so we were contaminating that river. In Ecuador and in most parts of the world, really, the strategy for dealing with sewage water, for all the water that we contaminate with our poop, right, is basically just send it into the nearest river. That's been the strategy for millennia, and in most parts of the world, including Ecuador, that's still mostly what happens. When you guys are in Quito, do you guys stay a night in Quito?
Yeah.
Yeah, all the poop you flushed down the toilet in your hostel in Quito goes into a river called the Machangara, which flows into the Guayabamba River, which all these rivers flow into further south. So about 90% of Quito has no sewage treatment at all, and that's typical of most large cities in the world. Okay, in the United States, when we're talking about an urban sewage treatment system, right? Usually the strategy is you flush your poop down the toilet, it goes through a system of tubes or sewer system to a sewage treatment plant. That's what you guys have in Atlanta, for example, right? You have a big sewage treatment plant. A lot of the satellite communities all have their own systems, but basically what you were talking about is a big giant collection tank, and then it's fed into aeration tanks, right? Where you have these slow-moving propellers that oxygenate the water, and then the solids are sedimentated out of the water, and then that water is treated with chlorine usually, and then discharged into the nearest watershed. Okay, so does that work in terms of killing most of the fecal coliform bacteria? Yeah, works really well. But you've got a few disadvantages to a system like this. The biggest one from an environmental standpoint is that water, although it's free of fecal coliform bacteria, the bacteria that's in our poop, it's also full of dioxins and chlorine and stuff, and it's put into the local watershed, and it starts killing up and down the food chain. We're still putting toxic waste into our water system. Another disadvantage to those systems from just a municipal budget standpoint is that they're really expensive to A, build, and to B, maintain. You got to have a staff of people constantly monitoring them, making sure everything's working, fixing stuff that breaks, etc. And a typical system for a city of 40 or 50,000 people, like in Burlington, Vermont, near where I'm from, a system to treat the sewage for about 50,000 people, you're talking about a $10 million minimum in construction investment just to build the system, and then several $100,000 a year just in maintenance and employees. So it's really expensive. When we're talking about a system like this, we're talking about a philosophy called ecological design. Ecological design, what does it mean? It means nature, whether you believe in God or believe in Inti or believe in the Pachamama or whatever you believe in, nature is designed perfectly. It's perfectly designed to have balance and recycle everything perfectly, right? So ecological design, what ecological design does is you look at a civil engineering problem, like how do we treat all this poopy water, in this case, instead of creating this big expensive system which ends up contaminating the water downstream, say, what works in nature? How would nature take care of this problem? In this case, how does nature take care of filtering water? Through wetlands ecosystems. You guys ever been at the mouth of a river that flows into a lake or the ocean? What does that look like? What does that wetland area look like? It's marshy, it's full of reedy plants. And those plants are perfectly designed to be the most efficient plants in the world in terms of recycling and cleaning water. So a constructed wetland system for cleaning water is exactly that. All we're doing is taking that same idea from nature and replicating it in a controlled environment. Okay, so how does this work? All the sewage waste from Pucará, so all the water from toilets, all the water from sinks, all the water from washing clothes, comes down into this big tank over here. It's up there on the hill. Okay. Inside that tank, there's 3 chambers, and each chamber has a special conduit that allows for the water to pass to the next chamber, while all the grease and floaty stuff that gets into that tank stays on top. So we're not clogging up our system. Right, guys? And then once the water comes out of that tank, it's still full of fecal coliform bacteria. The last test I did was showing we've got a charge of fecal coliform bacteria, or a level of about 75,000 parts per million of fecal coliform, which is really, contaminated. If you drink that water, you would die, or get really sick. Okay, and so it comes out of this tank. It's still contaminated with lots of bacteria. It also has lots of phosphorus from soap. Soap has lots of phosphorus. It has lots of nitrogen, which is what our poop has a lot of, right? So it has bacteria, so nitrogen, phosphorus. The water then runs in a zigzag form through the first pool, the second one, and down here to the third one. And after it takes 4 or 5 days to get through the system, depending on how much water is moving through it. We can also adjust the water levels of each tank, and it comes out and it's discharging into the stream. The last test I did, which was about a month ago, it's coming out at 170 parts per million. So we're going from between 70 and 80,000 parts per million to 170 parts per million. In the United States, 170 parts per million fecal coliform is the EPA designated level for safe water that's safe to bathe in and stuff. So it's working really efficiently. A system like this, instead of costing $1 million, it costs about $10,000. There's virtually no upkeep beyond just keeping the weeds down, which is what we did this morning. You can see we came through this morning and cut all the grass. Yeah. And the only other real maintenance to do is every 2 or 3 years we got to come in and pull out some of these plants, because these plants are the happiest plants in the world. All they do all day is they've got their roots in a hydroponic system of nitrogen-rich water. They're just chilling all day long and just growing, and have this great environment that has all their nutritional needs met. All these plants I took out of natural wetland systems. So we've got a plant called the tifa, which is a kind of cattail native to the Andes. We've got a plant called the tortora, which is another plant you find in marshy areas. You can experiment and use all kinds of plants, but the reedy, marshy plants from wetland areas are the most efficient at absorbing through their biomass water. What happens is when those plants are constantly absorbing water into their biomass, that water is pulled up through with turgor pressure and then is evapotranspired into the atmosphere. One of these big tifas, is you don't see it, but it's evapotranspiring 10 to 20 liters of water into the air every day, right? So what happens is the water gets pulled up through the plant, gets evapotranspired into the air, and all the contaminants, whether they're bacteria, whether they're phosphorus, or they're nitrogen, in some cases heavy metals or toxic waste. A lot of times in Superfund sites in the United States where they're cleaning up toxic waste spills, the plant wetlands plants, and then they will chop them down and then put them in a sealed landfill or something. So all these plants, those bacteria get pulled up into the plant, and then because they don't have the oxygen and stuff they need to survive, they just die in the tissue of the plant. That's how it works. I'm not a scientist, but I do water quality testing here in a lot of places. I've been installing these systems in outside of the area, like up in Otavalo and Cotacachi, for people who want to have more ecological water on a domestic level, water treatment systems. And so I'm always going to these systems I've installed, as well as this one, and testing the water. And I can tell you, again, going from between 70 and 80,000 to less than 200 parts per million is a system that's working as well or better than any modern wastewater treatment center that we would have in a city or kind of scenario. So it's working with nature, seeing what works in nature, and just essentially replicating. That's what this system is doing. All right. Any Any questions?